Welcome to this environmental management video where we will be looking at rock formation. Before we get started, let's just take a moment to ask, why are we interested in how rocks form? Is it important? Does it have any impact on our daily lives? I want you to take a look around the room you're in now. What can you see? There might be a computer screen, a TV or a mobile phone, perhaps some electrical lights, maybe even a sofa or some chairs. Now ask yourself, where do all these things come from? If you said a shop, you're probably right, but I want to know where the shop got them from. Let's take the example of a smartphone. Perhaps you are thinking it came from the manufacturers. Of course, the manufacturers assemble the components, the battery, the screen, the microchips, the wires, the speakers, and so on. But what I'm really interested in is where the raw materials come from to make these components. Would you be surprised to find out that all the raw materials for a smartphone come from rocks and minerals that have been mined from the ground? The glass screen is made from silica and sand. The plastics are made from oil, which is extracted from under the sea floor. Light-emitting diodes are produced from gallium found in bauxite rocks. And there are many, many more raw materials which all come from rocks and minerals which are mined all over the earth. Virtually all the objects around us in everyday life are available to us because of the rocks and minerals naturally found on earth. And how rocks are formed all of a sudden becomes important because the properties of these rocks and minerals determine what we can extract from them. Earth is a rocky planet. Let us take a closer look at the structure of the Earth. It was formed about 4.5 billion years ago. It has a core consisting of iron, and it is surrounded by molten rocks which make up the mantle. Humans only use the outermost layer, which is called the crust. This is where we find the rocks and minerals that we mine. Underneath the ocean, we call it the oceanic crust. It is what makes up the sea floor. Under the land, we call it the continental crust. Oceanic crust is thinner and denser than continental crust. So, we know that all the rocks and minerals we use on Earth come from the outermost layer of the Earth, known as the crust. But are all rocks the same? No, they aren't. We can actually sort the rock into three main categories, depending on how they were formed. The first one we will look at is igneous rocks. When the hot molten magma of the mantle rises, it cools near the crust, turning into a solid rock known as igneous rock. Sometimes the molten rock comes straight to the surface of the Earth during a volcanic eruption. It is then known as lava until it cools and forms igneous rock. Igneous rocks usually contain crystals. If the lava from a volcano cools quickly, only small crystals have chance to form. However, magma, which cools very slowly underground, can contain large crystals. Take a look at these igneous rocks. Granite, basalt, and pumice are all igneous rocks. Can you think of where we might see these rocks used by humans? Granite is often used as countertops in kitchens. It is used in buildings and for carving structures, like these at Mount Rushmore. Basalt is also used for carving statues and in buildings. Many ancient Egyptian sculptures were cut from basalt. It was even used as flooring inside the pyramids. Have you ever seen a pumice rock sat next to someone's bathtub? These rough rocks are often used to rub off dead skin from people's feet. It is even used in toothpaste and cosmetics. The second category we're going to look at is sedimentary rock. Let's take a look at how these form. So existing rocks on the surface of the Earth are subjected to weathering and erosion. Wind, rain, snow, rivers and waves can all gradually erode the surface of the rocks, causing smaller particles. These accumulate over time to form a layer of sediment. With more time, new layers form over the old layers, which become compacted due to the pressure from above. The result is the formation of sedimentary rocks. Sedimentary rocks can contain different sized particles and may even contain fossils. Fossils occur when plant or animal matter falls in the sediment layers. Here are some sedimentary rocks: limestone, sandstone and shale. Can you think of anywhere you have seen sedimentary rocks used? Sandstone is often used for patio slabs in people's gardens. Shale is used in pottery and tiles, and limestone is used in water treatment and paper production. The third category of rocks is known as metamorphic rock. These are created when other existing rocks are exposed to high pressure or temperature. The structure of the rock crystals are changed, creating a new metamorphic rock. Examples of metamorphic rock include marble and slate. Marble is used in the construction of buildings and monuments. Perhaps one of the most famous buildings built of marble is the Taj Mahal in India. Slate is also used in construction. Have you ever seen a building with a slate floor or a slate roof? The rocks that make up the Earth's crust are always moving, just very slowly. All rock types can be eroded and form into new rock types. The interactions of the rocks and how they are formed can be represented by the rock cycle. So in summary, rocks and minerals play a huge role in our everyday lives. Found in the outer crust of the Earth, there are three types of rock: igneous rocks, which are produced when molten magma or lava cools; sedimentary rocks, which are formed when existing rocks on the Earth's surface are subject to erosion and weathering. The smaller particles accumulate to form layers of sediment. Over time, pressure from newly formed layers above results in the creation of sedimentary rocks. And finally, metamorphic rocks, which are formed when existing rocks are exposed to heat and pressure, causing a change in the structure of the rock crystals. Over time, rocks change between these three forms and can be represented by the rock cycle. I hope you have found today's video useful. Now we know how essential rocks and minerals are to our everyday lives. Join us next time to discover how we can find and extract them ready for use.